We're now going to look at problems where you're given a curve, however it has an unknown constant, but you are given information about a turning point that is on the curve. You need to use the information to work out the value of k. So what we need to do is set up an equation somehow with just k in it and then solve it. In order to get this equation with just k in it, we have to proceed as if we're going to find the x-coordinate of the turning point, even though we know it. Because if we do that, we should eventually get an equation with k in it. So we're going to write down the curve to begin with. Because we're going to be differentiating shortly to get the x-coordinate of the turning point, we need to get rid of brackets. So multiply out the brackets. We're going to get 2x cubed minus 2kx plus x squared minus k. Okay, let's get the general gradient at any point in this curve. And the general gradient, remember, is dy by dx. So differentiate the first term, we're just going to get 6x squared. Now differentiate the second term, remember k is just a constant here, it's just an unknown number. So overall this is an x term. So when you differentiate an x term with a power of 1, you essentially are just left with a coefficient of x. So we're just going to be left with minus 2k. And then differentiate this term, we're just going to be left with plus 2x. And then remember, k is a number, so when you differentiate a number term, it just disappears. So that is the general gradient at any point. What we're going to do is we're going to get the x-coordinate of the turning point. So at the turning point, the general gradient is equal to the actual gradient at that point, which is 0. So we set dy by dx, general gradient at any point, equal to the actual gradient at that point, which is 0. Because at a turning point, the actual gradient of the tangent is 0. It's a horizontal line. So we now have 6x squared minus 2k plus 2x equals 0. So all of a sudden we now have an equation with k in it, but the other problem is we've also got x in it, so we need to somehow get rid of x. Now think about what happens when you solve this equation. You're finding the x coordinates of the turning points. Now we already know that the x-coordinate of a turning point is 1. So what that means is 1 is going to be a solution of this equation. X equals 1 is going to be a solution. So what that means is you can sub in x equals 1. So x equals 1 is a solution of this equation. So because it's a solution, we can sub it into the equation. So let's sub x as 1 in. So we're going to get 6 times 1 squared minus 2k plus 2 times 1, and that equals 0. So we're going to be left with 6 minus 2k plus 2 equals 0. So we're going to be left with 8 equals 2k and then we're going to be left with k is equal to 4. So there's our answer for part A. We've now worked out the unknown constant in this curve. Okay, part B then says, now go and find the coordinates of the stationary points and determine the nature of each of them. So this is now really what we've been doing before. Okay, so to get the turning points, we need to start with the x coordinates of the turning points. So we're kind of going back again. X coordinates of turning points. So remember, we set dy by dx equal to 0. And remember, the equation that we had was this one. So I'm going to copy this equation down again, but then I'm going to sub in k as 4. So we're going to have 6x squared minus 2k plus 2x equals 0. Okay, so we're now going to sub in k equals 4. So we're going to get 6x squared plus 2x. I'm just reordering it here, putting the plus 2x after the x squared term. And then minus 2 multiplied by 4 is going to give us minus 8. And that's equal to 0. So we've now got a quadratic equation. Now, we're going to solve this to get the x coordinates of the turning points. We will be expecting one of the solutions to be x equals 1, because we were told in the question that one of the turning points, the x coordinate is 1. So I'm going to divide through by 2 first. So we're going to have 3x squared plus x minus 4 equals 0, and then we're going to use product and sum. So product minus 12, sum plus 1, so our two numbers will have to be plus 4 and minus 3, and then we just do our usual, we factorise in pairs. So product of two brackets equals 0. So first bracket equals 0, so that means that 3x must equal minus 4, or x equals 1. There you go, see what I mean? We expected x equal 1 to be a solution. And then divide by 3, we're going to get x equals minus 4 over 3. So what we've just found then are the x coordinates of the turning points. So what happens now is we have to sub those into the curve to get the y coordinates. So we're going back up to the top here. We're subbing them into this, and remember k is now 4. So y coordinates of turning points. So let's start with the first x coordinate here, which was minus 4 over 3. So when x equals we're going to chuck it into the curve. So y is going to be equal to, and then if you just have a wee sneaky look over here, so I'm using this version, the version of the curve when we got rid of the brackets. So we've got 2x cubed, so that's going to be 2 times minus 4 thirds cubed, and then flick over again. We've got minus 2kx, so I need to sub in k is 4, and I need to sub in x is minus 4 over 3. So that's going to be minus 2 times 4, and then x was minus 4 over 3. Okay, and then flick back over again. And then we've got plus x squared. So plus minus 4 over 3 all squared. And then finally, don't forget about chucking the value of k in, which was 4. So it's going to be minus and then 4. So just be careful. So okay, so we've got a lot of tidying up to do here. So well, you could type the whole thing into your calculator, but I'm just going to do the powers separately just to be careful here, and then I'll type it in. So I'm going to cube this, minus 4 over 3 times minus 4 over 3 times minus 4 over 3. So if you raise a negative to an odd power, it's still going to be negative. 4 cubed is going to be 64. And then 3 cubed, 3 3s are 9, 9 3s are 27. Okay, tidy this one up. So this whole term is going to be positive because we're multiplying two negatives there. And then multiply the top numbers. 2 times 4 is 8. 8 4s are 32. And then that's over 3. And then we've got plus. And then we're squaring a negative. Raise a negative to an even power, it's always going to be positive. So 4 squared, that's 16 over 3 squared is 9. And then subtract 4. So now's a good time to go to your calculator, now that we've got rid of powers, and type everything in carefully. Okay, so I've typed that into my calculator and I'm getting 100 over 27. Or change it into a mixed fraction, hit your Shift SD button, so that's going to be 3 and 19 over 27. Okay, and then we've now got to get the y coordinate of the other turning point. So we're now chucking the x coordinate of 1 in. So when x equals 1, so this time we're going to have y equals 2 times 1 cubed minus 2 times 4, remember that's the value of k, and then times 1 plus 1 all squared, and then don't forget we're subtracting 4 the value of k. So this one's a bit easier to do then. So our first term is going to boil down to 2 and then minus 8, and then we've got plus 1 and then minus 4. 2 minus 8 is going to give us minus 6. Minus 6 plus 1 is minus 5, minus 4 is going to give us minus 9. Okay, so our two turning points are, first one, turning point is minus 4/3, 3 and 19 over 27. And then the second one, the turning point is, so x is 1, y is negative 9. So still a bit of work to do, but nearly there. Okay, now let's get the nature of the turning points. So nature of turning points, we need the second derivative d2y by dx squared. So if we flick back, we have to differentiate dy by dx. So if you remember, There was dy by dx with k in it, so differentiate the first term here, we're going to get 12x. Okay, and then flick back. Differentiate the second term. Now remember, k is just a constant, so minus 2k is a constant, so when you differentiate that, that just disappears, that's nothing. And then differentiate plus 2x, you're just going to be left with plus 2. Okay, so plan now is we're going to sub the x coordinate of each turning point into the second derivative to work out whether it's a max, a min, or possibly a point of inflection. So when x equals minus 4/3, the second derivative is 12 times minus 4/3, and then we're adding on 2. So 3 goes into itself once, goes into 12 4 times, so we're going to have minus 16 plus 2, so that's going to give us minus 14. So minus 14 is less than 0, so therefore that is going to give us a maximum turning point. Okay, let's chuck in x is 1. So the second derivative, d2y by dx squared, so this time is going to be 12 multiplied by 1 plus 2. So that's going to give us 12 plus 2, which is going to give us 14, and that's greater than 0. So when the second derivative is greater than 0, that implies it's a minimum turning point. Okay. So final answer, put it all together. So the first turning point was minus 4/3, 3 and 19 over 27, and it was a maximum. And then the other turning point, which was 1 minus 9, and it is a minimum turning point. So that's our answer for part B. Okay, next one then, part C. Going back to the question, part C says find the rate of change of the gradient at the point where x equals 3. Now rate of change of gradient means the second derivative. Rate of change of gradient is d2y by dx squared. So we want to find the value of d2y by dx squared when x equals 3. So we flick back. We've already worked out the second derivative, so we're just going to chuck in x is 3. So for part C, d2y by dx squared equals 12x plus 2. So when x equals 3, d2y by dx squared is going to be 12 multiplied by 3 plus 3. So that's going to be 36 plus 3, which is going to give us 39. And that's it. That's the rate of change of the gradient at the point where x equals 3.